Hello, welcome to the video. In this section, we're going to be looking at 5.1, where we're going to look at angles of triangles. So in this section, we're going to look at various classifications of triangles and being able to determine what kind of a triangle it is uh, from the questions that they may ask us or the examples that they may give us. So when it comes to triangles, there's two different types of classifications. You can either classify triangles by its sides, or you can classify triangles by its angles. So if you look at sides, there are three different types of triangles. You can either have a scalene triangle, which means that none of the sides are congruent. You can have an isosceles triangle where you have at least two congruent sides, and you can tell by the hash marks here and here. And then finally, you can have an equilateral triangle where all three sides are congruent. When you look at classifying triangles um, by angles, you can say, well, you can have a triangle can be an acute triangle, which means that every single angle, every single interior angle of that triangle is less than 90 degrees. You can have a right triangle where one of the angles is exactly 90, and in this case, it's represented by that square box. We have an obtuse triangle. Obtuse triangle means you have one obtuse angle, and in this case, it would be this particular interior angle here. And then finally, the last classification for angles would be an equal angular triangle where um, all three angles are congruent. Okay. So to start this notes, they are asking us to draw an obtuse isosceles triangle. All right. So they're asking us classifications in two things. They want a triangle that is going to fit the classifications for its sides, isosceles, and for its angles, obtuse. So in this particular instance, when you are drawing these, placing the hash marks correctly is very, very important. So, if I look at something like this, I'm going to try to make this angle right here uh, greater than 90 degrees by the definition of obtuse. So, but I'm also going to put hash marks here and here to illustrate that those two sides are supposed to be congruent. Okay, so that would be my obtuse isosceles triangle. For an acute scalene, I can draw it basically similar to how um, the diagram showed. And I'm not going to put any hash marks because one, none of the sides are equal. I guess you could do something like this to let them know that all three sides are not equal. You could do that if you'd like. Um, but yeah, so, and those three interior angles are in fact less than 90 degrees. Here we have a triangle that is in a coordinate plane, so we have coordinates there, and it's triangle OPQ. And they want to know, it says classify it by its sides, and then they want you to determine um, whether the triangle is a right triangle. So right now, I know that just by looking at it, that line segment PO is not going to be the same as PQ or OQ. So now the real question is it going to be isosceles? So I want to know if PQ line segment is going to be the same as QO. All right, that is my question. All right, in order to figure that out, we have to use the distance formula. So let's look at PQ. So PQ, take the square root. So my x values are going to be what, -1 minus 6 quantity squared plus, and then my y values are going to be 2 minus 3 quantity squared. So looking at this, I get -1 minus 6, -7, square that, I get 49. So I get the square root of 49. And I get 2 minus 3, -1, square that, I get 1. So I get square root of 50. All right, all I want to know is now, is QO going to give me the square root of 50? So let's take a look. So taking the square root of this, I get 6 minus 0 squared plus 3 minus 0 squared. So 6 minus 0 is 6. 6 squared is 36. So I got 36 plus 3 minus 0 is 3. 3 squared is what, 9? So 36 plus 9 is 45. So I got the square root of 45. So they are not going to be the same. So I can say now that all three sides are not the same. So if I were to classify this by its sides, because none of the sides are congruent, we are going to say that this is a scalene triangle. Okay, so that's the first thing. The second thing on here, it asks to determine whether it is a right triangle. So the one that looks like a right triangle looks like it's right here at the origin. So for coordinates to be a right angle, they have to be perpendicular to each other. So looking at the slope, let's look at the slope of PO. So PO is going to be down 2 to the right 1, so it's -2 over 1. So if I looked at the slope of QO, it looks like it's, or OQ we'll say, it's going up 3 to the right 6, so that's going to be 3 over 6, which reduces to 1/2. Is -2 and +1/2 opposite reciprocals of each other? The answer is yes. They are opposite reciprocals of each other. So since they are opposite reciprocals of each other, I can say that this is also a right triangle. In this one here, it says triangle ABC has vertices 0, 0, 3, 3, and -3, 3. They ask you to classify it, then determine whether it is a right angle. So we're classifying it by its sides. So look here, look here. Uh, A is right here. B is 1, 2, 3, 1, 2, 3. So that's B. And then C is 1, 2, 3, 1, 2, 3. So it's right there. C. So here's my triangle, ABC. Now, what I know is that since basically B and C are kind of mirrored images of each other off of the y-axis, they're the same distance from the origin. So I can say that this distance here, AB, is the same as this distance here of AC. The one thing that I do have to look at is CB the same as like AB to see if it's equilateral. So if I went like that, so this is 3 comma 3, and this is -3 comma 3. So I'm basically trying to see is like CB equal to like AB, or AC. So I can go over here looking at, let's look at CB right off the bat. This is going to be negative 3 minus 3 squared plus 3 minus 3 squared. So this is going to be negative 3 minus 3 is negative 6. Negative 6 squared is 36. And this is going to be 0. So my answer is 6. So I want to see if AB is going to give me 6. So if I go here, this is 0. So I got 3 minus 0 squared plus 3 minus 0 squared. 3 minus 0 is 0, so this is going to give me 9 plus 9, which is 18, so it's the square root of 18. Square root of 18 is not going to give me 6. So the only two line segments that are equal to each other are AB and AC. So in this particular instance, this is an isosceles triangle by classification of its sides. Looking at if it is a right triangle, I want to see if the vertice of point A is a right angle. The only way that is a right angle is if the slopes are opposite reciprocals. So if I look at um, C to A, it's down 3 to the right 3, so CA has a slope of negative 1. If I looked at the slope of AB, it's up 3 to the right 3, that is positive 1. Well, negative 1 and 1 are in fact opposite reciprocals of each other, so I can say that that angle is in fact 90 degrees. So in this particular instance, this is a isosceles right triangle. We have a couple of theorems that are going to help us as we kind of move forward with characteristics of triangles. First one is the Triangle Sum Theorem. So if you have interior angles of a triangle and you were going to add up all of these interior angles, the sums are always going to be equal to 180 degrees. If you have um, an exterior angle, such as an exterior angle here like angle 1, the exterior angles theorem states that that angle 1 is going to be equal to the sum of the two non-adjacent interior angles of that triangle. So in this case, it's A plus angle B will equal the measure of angle 1. So to use that, we have an example with an exterior angle here. We have an exterior angle of 2x minus 5. We have two non-adjacent interior angles in this, and it says 70, and it has J. So question is, they want us to find JKM. So they're actually wanting us to find this angle here. But in order to find that, we need to find x. So in order to find x, this is going to be 70 plus x is equal to 2x minus 5 by utilizing um, the exterior angles theorem. So what I'm going to do is subtract x to both sides, and I'm actually going to add 5 to both sides. Cancels these out here and here. I get 75 equals x. All right, so 75 equals x doesn't answer the question. All right, it's wanting to know what that measurement is of this red angle that I just drew here. So in order to find it, you're just going to take 2 times it by 75 minus 5. So 2 times 75 is 150 minus 5 is, so essentially the measurement of angle JKM is 145 degrees. And that is looking at angles of triangles. Hope this helps. Until next time.